around in a watch, but really through the 1990s, 2000s, the technology really came up a lot, which is when it started to be used as an emergency safety product. We're also associated with the Photoluminescent Safety Products Association, who are the same similar group in Europe and the UK, and the Photoluminescent Safety Association, which carries out that function in the USA and Canada. So thank you to our sponsor. Keith and his team have set all this up and funding all this, so there's great effort there, spreading the word and making sure that we're all up to date in a technological sense. Now, there is a lot of detail in the presentation, but we're going to send out printouts or email the files of all the slides. So don't worry too much about taking notes. Let's try and just keep it interactive, and we'll email it out to you. Okay, so today we're going to look at technical background, how the photoluminescent products work, what are the technical strengths. Then we'll look at the international standards that we're going to cover, and just explain how each of those standards work and where their strengths and weaknesses are. Then we'll have a break. They'll be having some pastries and tea and coffee out in the foyer there. And after the break, we'll actually go through each of the 3 clauses of the fire code that we're going to be looking at. Emergency evacuation plans, exit marking, which are exit signs, and illumination of means of egress or emergency lighting. And the final thing is the quality assurance. Okay, if you want to use these systems and these products, how do you make sure that what you want is the thing that's actually installed? That's difficult in every country in the world. There are always substitutions, I suppose. Okay. Up. Right. So, technical background. What is photoluminescence? It's a terrible word to try and spell. It's even worse when you've got to say it a number of times in a presentation. It's tricky. First of all, what isn't photoluminescence? So it's not reflectance. So reflective materials, the light goes from a light source and is immediately reflected. So like a motorway sign, any sort of reflectance is common. But the key thing is that the light is emitted straight back immediately. So a photoluminescent panel, the light or daylight is emitted onto the surface of the photoluminescent material. When the light is absorbed into the panel, the light source is turned off. Now that light source could be an LED, a fluorescent, it can just be natural daylight as well. But the key thing is when the light is turned off, the light energy is re-emitted from the panel. And then the other key thing is that long after the light source has been turned off, it will keep emitting it. And the key thing with photoluminescent products is their ability, or a manufacturer's ability, to measure how long that will be visible for. So if you have this much light to charge it, how long will people be able to see that the exit is over there? That's the critical thing in the whole manufacturing process. Terminology, in some places, probably more the US, the material is known as PLM, photoluminescent material. Most of the rest of the world just refers to it as PL. So if you hear someone say it's a PL sign, it just means it's a photoluminescent sign. As I said, it can absorb light, and it's the UV end of the light spectrum. So it's the, if you like, the blue end of the rainbow, not the red end. So that means that sunlight, obviously, well, it's the most rich source of UV. So daylight is the best charge source for materials. So any stairway that has glass, a lot of glass around it, it will charge enough to make that stairway visible all night, as long as the sun keeps rising each day. As I said, it doesn't need to be direct sunlight, it's just daylight. Think about a photoluminescent panel as a storage cell. It is playing the role of a battery. A battery, or a rechargeable battery, is charged by the energy and remits that energy, or stores that energy. The photoluminescent panel does exactly the same thing. In fact, in hybrid signs now, the photoluminescent panel is referred to as an energy caching panel, which is an American term for saving energy storage saving. Most commercial lighting will charge photoluminescent, so LEDs, fluorescent, metal halide are all good charging sources. Old incandescent lights not so good, because that's more of the red end of the spectrum. So the colour temperature is anything over 4,000. So that's the stuff on the blue end of the spectrum. But most bulbs, it will have a colour temperature on the packaging, so you can easily see that. As I said, natural daylight is the most effective, and it doesn't need to be direct sunlight. If there's a stairway outdoors, we'll come to this again a bit later, but it's fail-safe. Like a stairway outdoors with good quality, durable photoluminescent materials on it, you'll be able to see that all night, no matter when the power fails or whenever the disaster is. So this is when a photoluminescent material charges. This is a logarithmic scale. So up here is how bright is it. Along here is how long. So it's limits. So that's 36 must be 6 hours there. So what, again, I was talking about how the whole the safety factor is based on the manufacturing technique and the ability to predict these curves and make sure that they happen repeatedly every time. So when a photoluminescent material is fully charged, it's very, very hot. This line here is what is visible, right? So that line has been defined as visible for a material on an edge of a step. It changes slightly for different products. So a step edging 15 millicandelas is very visible, but for an exit sign, that would be 30 millicandelas, because not only do you have to see the sign, but you have to read what's on the sign. So as you can see, in the initial minutes, when a material is fully charged, it's very high and it drops away. Over time, it sort of peters out along there. So the key thing in terms of the testing is where do these two lines intersect. And usually, we put a buffer in there as well. So, like most safety, fire safety things are built around 90 minutes. So that's something, right? So you can see it's well above the minimum visibility. I mentioned PSPA, that's the European Association. They've actually structured a series of classes of how bright is what the performance of the material is. The way it's usually done in Asia Pacific is that you apply an S factor. What is the S rating of this material? So typically an exit sign, as I said, would be around this, an S20 material or PSPA Class G. But if you come across PSPA classes in terms of a design or anything like that, I'm sure you can just check with Keith and they can translate into what sort of product will meet those class factors. Okay, one of the great things about photoluminescent material is it just charges and recharges continuously. There is no half-life like with a lot of minerals. There's a half-life. How long will this keep doing the job? Photoluminescent materials, they don't give up. They just keep repeating the process over and over again. Now, that means that you can say, well, that's great, because therefore all products are durable. That's not the case, because then you've got to say, what is the photoluminescent molecule carried in? And it's not the photoluminescent molecule that will degrade, it's the carrier that will degrade. I'll come to in a minute. So one of the great things with photoluminescence, it will recharge immediately, very quickly. So with batteries, it can take up to 16. Well, most batteries and signs will take at least 16 hours to recharge fully if they've been totally run down. The photoluminescent material will recharge within minutes. So that becomes significant if, being from New Zealand, I know a lot about earthquakes, and I know I lived through a big one in 2011, and you get that first shock and all the power goes out, and then, okay, it's all over. Well, no, it's not over, because then another hour or 2 hours later there are more earthquakes. So you can see if the emergency lighting or emergency exit signs are activated in the first shock or first event, they run themselves down in the neighbourhood for really 16 hours or 20 hours after that. Photoluminescent material can fill that gap for you. So I was talking about how photoluminescent, the actual molecules keep going, but you need to be careful about what sort of material is holding those photoluminescent molecules. So there is a manufacturing method that a few manufacturers, Ecoglo and a few others use. It's called HTC, high temperature curing. So it actually drops as a powder, the photoluminescent material, and a carrier, a customised carrier, let's call it, into aluminum strips or onto aluminum sheets. They then go into an oven at 160 degrees, and I think it varies from manufacturer to manufacturer, but it's probably, they're in that 160 degrees for 10 or 15 minutes, something in that area, and that cures the whole material. So it actually is integrally bonded to the aluminum then. It also means that the material holding the photoluminescent molecules is very stable. HTC products, they'll also charge rapidly, they don't shrink or delaminate, and I'll show you some examples of that in a moment. And most of the manufacturers around using those techniques will have warranties of up to 30 years for indoor use and 15 years for outdoor use. You may say, well, why is the warranty for outdoor use shorter? It's not so much the photoluminescent material, it's the ink of the graphics of whatever is, whether it's exit or whether it's a disaster preparedness sign, but over time the actual print will fade in the sun. So non-HTC products, you may have come across photoluminescent tapes. This is from around the late 2000s. And after 9/11, 2001, New York City introduced a whole building, or reviewed its whole building code. And one of the things they did was said that, okay, all buildings over 5 stories high, I think it was at the time, need to have photoluminescent materials in all the stairways. They had an experience in 1993 where there was a bomb put in the car park of the World Trade Center. That was in 93, and it took, it knocked out the generators because it was in the car park down below, and it took about 8 or 10 hours to get people out of the building because they were coming down all those stairs, 110 stories in total darkness. This is 1993. Now people have cell phones, so it's a bit easier. But that's the reason that, when 9/11 happened in 2001, they'd already put in some photoluminescent materials, and it just helped people get out faster. So they actually put that into the New York building code, and then the whole US building code a few years later. And what wasn't done initially was to think about durability. So you can get a photoluminescent tape that blows, that's good, but the humidity, like especially in New York, it's probably similar here, the humidity in some of those stairwells is very, very high, and it just doesn't take much for a tape to start delaminating. This is actually, this stuff's from Singapore, where in some housing development board buildings, product was put in. Again, you can see that these aren't HTC products, but the material, although it was put onto aluminum backing, it's starting to delaminate off. You can see the same there. So this is, again, this is not an HTC product, but it's made to look like one. And you can see it's just this delamination. It's actually really easy to spot it. If you're looking for it, you get your car keys out and you just dig them in the end, and the material will start flicking out. If it's HTC and it's actually cured, you can get a really sharp object and you can get a little bit off, but it won't start the whole thing coming out. Okay, so that's about the product. So, just a bit about the technical background about the system, how the systems work. In research studies that have been done about emergency egress with standard emergency lighting, they soon found that, okay, the lights are up there, they'll work, and when you go in there by yourself and you have a look, yep, it's great. You can see the stairs, everything works fine. But once you get the crowd effect and you get all these people who are in the stairway together, probably quite close, all feeling a bit panicked, they're also blocking the light from above. And here, the shadow is actually covering the steps. And what that does, it just slows everyone down quite significantly in terms of meters per second that they would cover the stairway. If the photoluminescent material's there, you've still got the shadow, but the light is actually being emitted from the edge of the step. It's not dependent on the light above. So they found in these studies that egress speeds increase with good photoluminescent systems. Okay, with smoke usually rises. So that is what a photoluminescent system typically would look like in a building in the USA. You would have your standard, whatever your standard spec for your exit sign is above the door. And they also have what's called a low level or floor proximity sign, which we can come back to later. Okay, so you have a fire event, the smoke starts filling from the top, and clearly it starts obscuring the higher products. And if you lose the lights, that's what it looks like. Now, the thing is, like, no product, whether it's electrical or photoluminescent, will be visible for a really thick, dense smoke. It just can't happen. But, as I said, it usually fills from the top, so with low floor proximity products, it just gives people so much more time to get out. The stats of deaths, and I think these are Australian stats, but with deaths in fire events, they usually happen with people within 15 metres of the exit, but they can't see, the smoke's overcome them. So, just by doing these things, it just extends that, or makes their travel a bit quicker and gives them a bit more time to get out. Okay, so that's sort of the background to the products and how the products are manufactured and how systems are put together. That's right. Okay. So now we're just going to go through the key international standards that are used, and we've drawn them from all around the world. USA, New Zealand, Australia are probably now leading the way in terms of the way the standards are being used. Europe, interestingly, is up to date in this sort of area. because they've been making photoluminescent products for longer, so all their standards are quite low. You know, they're written for that lower level material that that I was referring to earlier. So it means you can't use those standards for more critical situations like fire safety. Okay, just again, the three clauses of the fire code that we're looking at are emergency evacuation plans commonly, exit marking, which we call exit signs, and illumination of means of egress, commonly called emergency lighting. Okay, so for evacuation plans, the two key standards, NFPA 170 is the key standard. That is named in the Fire Code of the Philippines for a couple of different aspects, which I'll cover later. We've also put in ISO standard because on the evacuation plans, all of the things that are marked, they don't all have symbols in NFP 170, but ISO has most of the others, except one, which I'll tell you about soon. Okay. Let's see. For exit signs, there are a few standards that we're going to use. This specification was just passed by Standards Australia, actually it was 2021. So it was first published in 2021. It had been worked on for about 5 years before that. But this is the only standard in the world currently for what we call hybrid LED photoluminescent exit signs. I'll tell you a little bit more about how they work later. For what we call passive photoluminescent signs, the Building Code of Australia has a specification for how those signs should be tested and should operate. Again, later I'll show you examples of this, but what it's always talking about is charging the sign with 54 lux on the face of the sign for 60 minutes. That's a really common benchmark in a whole lot of these standards. So if you're using photoluminescent materials, either you've got daylight, which is charging it all the time. If it's a fully enclosed space, the lights need to be on, or 54 lux of light, which isn't much, but it needs to be on for 60 minutes before operation. So commonly in a shopping mall or somewhere, the lights will just come up a bit for 60 minutes before there is public entry. Once it's charged, once it's had its 60 minutes, clearly all through the day it's charging more and more and more. So that 54 lux for 60 minutes is where remember that red line intersected the decay curve. So that really, that makes sure it meets that. So the more charge it has, the more visible it is later. There's another specification that is used, which is an AIDS-TM test. Now, these two are always used together. You'll see them 7 quoted as ASTM E2072/E2073. The reason for that is that this bit contains the numbers of how bright the product needs to be. This one defines the test method. So the test method being what temperature is the test carried out at, all those factors around control of the testing. Okay, UL 1994, the very, very common standard. That's the one that is generally used in the USA for this type of system. As I said, it's pretty well always 1.5 hours and 90 minutes. I think it's all 90 minutes here. Yeah. I think Thailand is a bit more. I think it might be 120 minutes in Thailand, but there are not many places that it's not 90 minutes. With these standards, and I'll keep repeating it, but pretty well all of these standards use the ISO running man symbol. They don't use the word exit. So when we're applying them to the Philippines fire code, we say, okay, we're going to use the word exit, but we're going to use the luminance requirements. So the material has passed the standard, and the material has the luminance factors for visibility, but we'll use the word exit instead of a running man. And of course, the USA also uses exit, but that's about it. Okay, so this is just to sort of show you how a system looks, a UL 1994 system or similar. So this entering the stairwell, and you have the light failure, sort of pixelated, but I think you get the idea. So the perimeter of all the landings is marked, the stairs are marked, and the handrails are marked. Exit signs if there are something. No, still going. But you get the idea of how it looks in a UL 1994 system. Okay, the PLC, one of the things we do, like PSPA, their brightness classifications, the PLC has written a number of standards, industry standards. This one is a test for durability for HTC products. So, you know, how do you know, apart from if you start digging away at it with the car keys and it falls to pieces, you probably know it's not HTC, but you want to know before that. So you ask for a test, an HTC test, and that puts samples again into an oven at 150 degrees for 20 minutes. And what they're looking at when they take it out, has it shrunk, is it cracked, is it in any way degraded? HTC products have no visible shrinkage, delamination or distortion or yellowing. Okay, the high luminance test, PLC's high luminance test. So I mentioned that UL 1994 is what the US uses in their stairways. So that's pretty well spread all across the US now. Originally it was only in new buildings. Now all the existing buildings are now being brought into the regime as well. But in the US, UL 1994, these systems are supplementary. So you have to have your electrical emergency lighting operating at a very high standard, and you need a UL 1994 system. So what the PLC has done, because in places like Australia and New Zealand, a system like this can totally replace emergency lighting. It can't in the Philippines because it specifically says it can't, but but the reason that we developed this high luminance test was so that it could and does replace electrical emergency lighting in New Zealand and Australia. And what it does, it says, well, do this UL 1994 test, using it as the test method and the conditioning, temperature and all those things. But once the lights stop, these are the levels that it has to meet. And that'll make a system that is visible enough to operate on its own. I'll come back to how that becomes useful in the Philippines. Come back to that soon.
What's MCD? What's MCD?
Millicandela per metre squared. I think the reckon term is maybe foot candles. Yeah. Yeah, so 1 foot candle is 11 lux, I think.
10.
Yeah, close. Okay, this is another durability test, and the reason we don't see it so much in this part of the world, it's part of the UL 1994 suite of tests that you can also have your material go through this durability test, so then it's rated for outdoor use. So you can, there are two ways to have a UL 1994 certificate, one for just indoor use, the other indoor or outdoor use. You can use this as a test method. So that sort of brings us to the break. Are there any questions you want to fire through again? If you've got questions, or else we can go and have a cup of tea, and there's some snacks and things out there. Please feel free to just let us have your questions of anything that's come up in this first part, and then when we come back, we're just going to look at each of those tests and how they actually connect to the specific parts of the environment. Okay, so yes, I'll just leave that up there, and let's go and have a tea or coffee.